Hello everyone, welcome to my next tutorial. In this tutorial, I will be discuss about design of passive thin film opticals. Basically means we consider an example, then discuss about the passive optical properties of thin film layer structures. And this section we will be demonstrate different anti-reflection coatings method. So before start of the tutorial, we will be study about what is anti-reflection coating so you can easily get what I want to discuss in here. Firstly, I want to introduce myself. I am Sahil Verma, application engineer of the well-known company Impulse Technology. Our company also have partnership with Nano Academic Technology, which is Canada-based company. They offer several softwares like Nano Decals. It is used for the material and device simulation. Second one is rescue. It is used for the material simulations. And third one is a QTCAD. It is used for the solid spin qubits. And Matra. It is a USA based company which is used for the cloud based material simulation. And Fluxim company. It is a Switzerland based company. They offer several softwares like Setfos, Laos, Philos, but in here we will be discuss about only Setfos softwares because we are performing our tutorial in Setfos. Our company also provide many of the services like software distributor, training program, technical supports, and equipment like micro probe station, solar cell, thin film, FET, gas sensor, transistor, and memristors. Company also have valuable customers like IIT Guwahati, IIT Madras, IISER Kolkata, IIT Dhanbad. A number of customers are present. They are using many of the softwares. For the more details our company, we can go with the impulsetechnology.in websites. In my first video, I have already explained about the Setfox tools and how we can use these softwares. Who has not seen it my previous video, please check out the playlist. In here we will be discuss about only design of passive thin film opticals. Basically we are considered here three different anti-reflection coatings method to demonstrate the passive thin film opticals properties. So we need to understand before the start of the tutorial what is the anti-reflective coating. It is a transparent film that reduces reflection on the surface of lenses, optical elements and photovoltaic cell. It is also known as anti-glare coatings. So in this diagram you can see that here it is a substrate and it is a anti-reflection coatings that given in here. It will help to reduce the reflections. Anti-reflection coatings are used for the many applications we can discuss in here. Imaging system, infrared light, laser application. In imaging system, it will be used for the improved efficiency by reducing light loss due to reflection, and infrared light enhance the transmission of higher wavelengths, improve sensitivity and image quality. In the laser application, must meet or exceed certain laser damage threshold requirements. It also used for the increased conversion efficiency of the solar cells. So many of the uses are given for the anti-reflection coatings. You can easily understand what I want to say in here. Basically, in this tutorial, we are going to simulate passive optical properties of thin film layer structures, and this tutorial demonstrates three film different anti-reflection coatings. For the simulation of these properties, we need to know for anti-reflectant coatings, optical thickness of the quarter wavelength, it can be d equal to lambda upon 4 refractive constants. In here, basically, we want to reduce the amount of the reflectance. It is known as a residual reflectance, that amount of the reflectance of a surface or optical element at a specific wavelength and angle of the incidence. Reflectance of a coated surface always less than the uncoated ones. So therefore we will be use anti-reflection coatings. If we study about these two slides, now we will be use these information in the Setfos tools. Click at the right side and run as a I have already explained about the Setfos in my previous video. Who has not seen it, please check out the playlist. In my first video, we have already discussed about how we can use Setfos, how we can characterize our properties. That's we want. Firstly, we will be do single layer anti-reflection coating. It is the first and simplest dielectric structure for this. It consists of single layer with an optical thickness of the quarter wavelength. Firstly, we will create a new simulation files through the plus I symbols, add more layers and give each layer name one by one. Film, glass. It is a extra layer, so you can remove through the minus I symbol. Now you need to give thickness. It will be 0 mm. For the film, it need to be quarter wavelength that I have already told about. So you need consider at here this. For the glass, we consider at here thickness 0 mm. So top and bottom layer are semi-infinite medium, so thickness are irrelevant at here. I have already told many of the times these things. For the film, you can see at here the anti-reflection coatings are created at here. For the thickness, you can change if you want 0.25. At here we calculated passive optics properties, so we need to put at here reflective constant 1.225. For the glass, you can choose at here 1.5. D equal to lambda upon 4 into refractive index of the coating layer. If you want zero reflectance at desired wavelength, so n equal to refractive index equal to root refractive index of air into refractive index of glass. So a great reduction in reflectance is obtained. It can be known as residual reflectance. That means amount of reflectance of surface or optical event at specific wavelength and angle of incidence. Reflectance of coated surface is always lower than the uncoated ones, provided that index of the reflections of coating between two media. At here, we specify a quarter wavelength for thickness of anti-reflection coating. So layer structure are completed in here. If you click passive optic settings, you can see at here shift wavelength vary from the 380 to 780. If you want to change steps, you can consider at here 5 and wavelength 550 nm and incident angle 0 degree. Now you need to activate shift setting tool and choose at here incident angle. You can vary from 0 to 45 and step you can consider at here 45 degree. So at here layer structures and passive optic settings and shift settings are completed. It is for the single layer anti-reflection coating. Now you can give at here your file name single layer anti-reflection coating. Run your file. So you can see at here the reflectance. At here optical profiles for the refractive index and passive optic properties are given. You can simply click and check one by one. It is transmittance. At here, if you click at here play button, you can see it here. The resulting reflectance spectrum is so the reflectance spectrum is V-shaped and is 0 at the design wavelength 550 nm. Reflectance spectra for S polarization of single layer anti-reflection coating curves refer to normal radiance and 45 degree incident angle. If you change at here incident angle and click at here the play button, you can see at here variation. Similar for the transmittance, you can see at here the changes. It is for the single layer anti-reflection coating structures. Now, if you want to create double layer anti-reflection coating structures, we can be designed again using quarter wavelength layer. Top layer it will be the same air, but if you want to change at here, that value you can easily change. Second layer you can give new name. It is magnesium fluoride. It is colorless to white crystalline. inorganic compound with variety of usage. You can add one more layer at here, magnesium oxide, and thickness you can consider at here 0.5. If you are not imported their files, you can put at here 1.38 for the magnesium oxide, 1.76. For the glass, you can change at here value. New value you can consider at here 1.46. Passive optic settings are similar as single layer anti-reflection coating. Now you can change at here the shift setting step value. It will be 5 degree. So for the double layer anti-reflection coating structures are completed. Now you can give at here new name for your new file and click at here play button. Now you can see at here the variation for the transmittance. It will be different to the single layer anti-reflection coating structures. And for the reflectance, click at here play button. Now you can see at here the variation, reflectant spectra for the S polarization and reflectant spectra for the P polarization. You can see at here the passive optic properties one by one. Similarly, we can create at here the triple layer anti-reflection coatings if you want. So now I'm going to create triple layer anti-reflection coating. A 3-layer coating can be designed again using quarter wavelength layer. In this case, generally we are doing at here reflectance is reduced in wide band around the design wavelength, and transmission continuously increases as each anti-reflection coatings that you are going to add. At here magnesium fluoride is similar that you choose in double layer anti-reflection coatings. In between you need to add one more layer and you can give at here new name magnesium hydroxide, but you will be change thickness value for the magnesium hydroxide. You can consider at here same 0.25 and at here new units you can consider at here quarter wavelength. You can see at here the anti-reflection coatings layer structures are created. Similarly, you can change at here constant value, it will be same. Passive optic settings will be similar as previous, and shift settings also will be similar as you choose in previous double layer anti-reflection coating. Now you can give at here new name triple layer anti-reflection coating and simply click at here play button. You can see at here the variation for the transmittance and reflectance. In this graph you can visualize even for a large incident angle the reflectance is very low, but for the transmittance it will be increases. Transmittance for the X polarization and transmittance for the P polarization. If you want to change at here incident angle, simply click at here the play button. Optical profile you can see at here and passive optic properties. You can see in this tutorial if you imported anti-reflectance coatings, so reflectance are continuously decreases but transmitted it increases. So I hope you understand how to create a layer structures and how we can calculate passive optic properties with the shift setting. So now I'm going to end it here my tutorial. If you have any query related to this, you can ask in comment box, and in the description box email are also given, so you can contact. Who has not seen it my previous video related to the Setfos, you can easily check out the playlist. If you want to book our demo or live demonstration, you can contact impulsetechnology.in. Thank you very much.